Good afternoon, Internet. I am Matt Booyak, and in this video, we'll be taking a look at the 50-second problem from the Project Euler Problem Archive. Now, this problem asks us to find the smallest positive integer such that the first 6 multiples of that integer contain exactly the same digits. And our approach to this problem is going to be pretty straightforward. We're just going to try each of the integers in order until we find our solution. One thing we will need, however, to make our code a bit more simple is a way of easily comparing whether two numbers have the same digits or not. And the way we're going to do that is to generate some kind of key for a given number such that if two different numbers have the same digits, they will have the same key. And the easiest way to do this, I think, is to convert our number to a string, sort the digits in descending order, and then convert that string back into an integer. And to see why we want to sort in descending order instead of ascending order, for example, let me just pull up Notepad real quick here. And we'll say, consider the number 301. And let's see what happens if we sort in ascending order instead. We would have the number 301 turn into the string 301. We would then sort that to get 0, 1, 3, which would give us the integer 13. Now, that's a problem because the number 13 is also going to have the key 13, but 301 and 13 obviously have different numbers of digits. And so we need a way to distinguish between, for example, 301 and 13. In particular, we need to avoid this case where the leading 0 is dropped. And we can do that just by doing sort descending instead. So that's going to give us 301 goes to the string 301, which is sorted to give us 310, which gives us the key 310. And obviously, this is a different key than 31, which is the key we would get for the number 13. Just to double check that this works as we intend, we'll now consider 130. And we would have the number 130 become the string 130. Sort descending would give us 310, and that gives us the key 310. And we see that 130 and 301 do, in fact, have the same key. And so because they have the same number of digits, the same number of times. And so keeping that in mind, let's get to writing some code. As usual, we will copy our template directory to make our problem directory, enter our problem directory, and open our main.cpp. Okay, so the first thing we want to do is write that getKey method that I was just describing. So let's do int getKey int n. And so first we're going to need to be able to use strings. So we'll say include string. And we also need to be able to sort the digits in our string. And so we're going to want to include algorithm also. Okay, so we'll say string digits is equal to toString n. And then we want to sort our digits. So we'll say digits.begin, digits.end. But this isn't quite what we want because the sort function by default, sorts in ascending order, not descending order. And there are a number of ways that you can kind of coax this function into doing what you want, but I think the most straightforward way is instead of giving it the iterator to the begin, or the beginning of the container and the end of the container, we're going to use reverse iterators instead. And you can do that just by adding an R at the beginning here. So this R begin is going to cause the iteration to actually start at the end and move to the beginning instead of starting at the beginning and moving to the end, as the names of these functions might suggest. And so even though this sort function is still going to be sorting in ascending order, we're kind of making it look at the string backwards, and so it will end up sorting it in descending order just as we want. Okay, so now we can just say return s2i digits. So this just converts from a string to an integer, and then we can return that. Okay, so now going to our main function, we're going to have our integer x. And x is going to start at 1 and go up to infinity, 1 at a time. We won't ever get to this line here, because as soon as we find our solution, we're just going to return directly from that point. Let's say int key is equal to get key x. We'll need this to compare to each of the other multiples. We'll need a variable to keep track of the multiple that we're currently considering. So let k be the multiplier for each multiple. We'll say for k is equal to 2. We already have x is the first multiple. Obviously, x has the same digits as itself, so we don't need to consider that case. So we'll start with k is equal to 2. K is going to be less than 7. Remember, we have to look at the first 6 multiples. And we'll increment k. Okay, so now we need to check if the key for the multiple of x is equal to the key for x. So we'll say if key is not equal to get key k times x, then we'll just break. Then obviously this is not our solution. Okay. On the other hand, if we manage to get through all 6 multiples and the keys match for all of them, when we exit this loop, k will be equal to 7 because we will have reached all the way to the end of the loop. You'll notice that even if we fail on the last multiple, k will be equal to 6, and we'll never actually increment up to 7. And so if at this point we say if k is equal to 7, that must indicate that we have found our solution. So we'll say printf solution is equal to %d, and that's just going to be equal to x. And then we can say return 0. All right, so let's go back to our shell and make and solve. And we have a candidate solution here. Let's just do a real easy check to see if it actually is correct. Obviously, in a moment, we'll check the archive just to make sure. But we can actually see what the multiples are. So we have 142,857 plus 142,857. So we see that this number has 1, 4, 2, 8, 5, and 7. That's the second multiple. 1, 4, 2, 8, 5, and 7. That's the third multiple. 1, 4, 2, 8, 5, and 7. That's the fourth multiple. 1, 4, 2, 8, 5, and 7. 5 multiples. And 1, 4, 2, 8, 5, and 7. all 6 multiples. So now let's go over to the archive, and we'll see if I'm still signed in. I am. We see the same answer right here. I'm closing out these other things. We see that it does, in fact, match. So, as always, thank you for joining me. Tomorrow we'll be tackling problem number 53.